Hello, Algebra 1 students. Mr. Ford here with the homework tutorial. This is 531, problems 85 through 90. Again, I got to fix this. I did update it, but not on this thing, apparently. No checkpoint question incoming on this one, but there is one coming up pretty soon here, but we'll get there when we get there. 585 is asking us to identify the following sequences as linear, exponential, or other. Linear would be ones that add. Exponential would be ones that multiply. And other would be not either of those. So, for the linear and exponential sequences, we got to identify the rate of change and whether or not it is a constant that is added or multiplied. Let's look at A. You can clearly tell me it's not adding, so that's not going to be an arithmetic sequence, or sorry, not linear. However, it is true that 12 times 12 is 144. And if we check on our calculator 144 times 12, you can tell that it is also 1728. So this is exponential. And we are multiplying by 12. I will show you the answer to this one and then probably let you go on the other ones. Well, I'll help you out a little bit. For question B, the fact that 0 is here is a dead giveaway. That kind of tells you that it's not going to be exponential because 0 times anything is 0. So it couldn't be exponential. So what you're doing here is I think you're looking to see if there's a pattern there. It's clearly going up by 5, plus 5, plus 5, plus 5. So at this stage, you need to tell me, is it linear or exponential, and what is the addition thing you're doing there? So I think you can tell me both those answers probably right now. Question C is interesting. It's not exponential because, again, it starts at 0, and 0 times anything is just 0, so it's not that. It's also not adding. Plus 4 takes you to 4, but plus 4 does not take you to 16. So it's not multiplying and it's not adding. So it's neither, but I'm going to have you write that down. Question D, again, it's not going to be adding because the decimals are getting bigger. It's usually a dead giveaway that it's not going to be a linear sequence. The decimals themselves are increasing. But here's a handy trick. If you take any of the numbers, like 2.25, and divide it by the previous number, you can also do the same trick with 3.375 divided by 2.25 or 5.0625 divided by 3.375. If you do these division problems, I think you'll see exactly what I want you to see. So if you're stuck on this problem, try dividing those three numbers. You should get the same answer for all three, and that will tell you what you're multiplying by to get this exponential sequence to work. But for the answers for this, I am looking for either the word exponential, linear, or neither, and what the actual thing is there. So you have to provide the answers to those questions. 586 is a system of equations problem. It's going to be a substitution system since y is equal to negative x minus 2. It's probably a good idea to put parentheses around it because that negative sign is going to cause some problems if we don't anticipate it. So let's take the bottom equation and let's rewrite it. This time we're going to replace y with negative x minus 2. Again, y is negative x minus 2, so we can replace it in the bottom equation. Just be careful when you're doing the distribution here because you have a negative 3 times a negative x, which makes it plus 3x, and a negative 3 times a negative 2, which makes it plus 6, equals 22. This is going to give you 8x plus 6 equals 22, and here's where I'm going to drop you off. You need to solve for x, and when you've got an answer, you want to take that answer and plug it back in up there and solve it for y. Just keep in mind that your answer is y is negative x minus 2. So whatever answer you have for x, you're going to take the opposite of it and then subtract 2. That should tell you what the two numbers are. 587, we kind of did during class here a little bit. We actually did A and B in class, and then C we also looked at a little bit. When you raise something to the negative first power, you move it to the bottom of a fraction, and if you raise it to the negative first power again, it moves back to the top. So this goes 2, 1/2, 2, 1/2, 2, 1/2. Next, we got a question leading up to what we're going to do in Chapter 6. We got the graph at right compares the gas mileage to the weight of numerous vehicles. Describe the association between these two quantities. When we are asked to describe the association, we're looking for a selection of words. It's going to be either, let's start with linear or nonlinear. It's going to be, let's see, positive or negative. And it's going to be either strong, moderate, or weak. It's one of those three. You need to pick out one word from each one of these sets to describe the association. It might be helpful if you start by drawing a line of best fit. Does a line make more sense, or does a curve make more sense for this graph? That's kind of a question that I'll leave you to consider on your own, but you can answer this question by choosing whichever words you think fit the best. I think no matter what, you're choosing a negative. I'll at least get you that one because it's going down. 589, we're finding the missing areas and dimensions from the generic rectangle below and writing each area as a sum and as a product. Let's take a look at A. I don't know what the dimension down here is, but I do know that it multiplies with 4x to make 16x squared. So we need 4, because 4 times 4 is 16, and we need another x, because x times x is going to be the x squared that we need. Let's see, what else can we get at this stage of the game? Well, the only thing that multiplies to 1, honestly, is 1 in itself. So I think at this stage we're safe to put a 1 and a 1 down here. Because the only thing I can think of that multiplies to 1 is 1. Or you can make it -1 and -1. So I think there are going to be two possible answers. I'm going to stick with the positive version for this. You can fill out the rest right now because 4x times 1 is going to be 4x. And 4x times 1 is also 4x. So as far as writing your answer as a product, I'll help you out with that. The product is a multiplication problem, and you're going to take the dimensions of your box and multiply them together. It's going to be 4x plus 1 times 4x plus 1. Or if you want to be fancy, 4x plus 1 squared. Now the sum, you are going to just add together all of the things that you have here. You've got a 16x squared, you've got two 4x's, and you got a 1. You can combine these two together, so please do that in your final answer, which you can do, I think, yourself. Over here on question B, again, kind of the same thing. We have a little more information, then we can actually do a lot more work in this one. Again, let's start with the 10y, which is 2y times something, and 2 times 5 is 10, so you got to have 5 up there. We can now fill in 5 times -3 is -15. And the last box down here, -3 times some unknown number is -12x. -3 times 4 will give us the thing we need, but we need the x also right there. I think that will do it, because then you'll get -12x. And then in the bottom left corner, you are going to have 4x times 2y, which is 8xy, just like so. I will leave you at this point to write the product using the other problem over there. Write the product and sum, because you are going to need those for your final answer. So use the other problem over there as a guide. For the product, you're just going to multiply together the dimensions, and for the sum, you're going to add them all up, what's in the box, like that. Oh, I lied. There is a checkpoint question on this one, so I guess we have that to tackle next too. So let's start about this problem is a checkpoint for writing the equation of a line, and it's referred to as checkpoint 5b. So here's the thing we got to practice. This one, since it's a checkpoint, I will walk you through the entire problem because we're going to look at a lot of examples of this too. So at the end of the day, in all these problems, we're going to write mx plus b. That's right there. And this is probably the most straightforward way I can show you to do this. We know that the m is going to be 2 because the slope is 2. So I'm going to plug that in to m right now and get y equals 2x plus b. Now, as far as finding out what b is, we don't know what that is, but we do know x and y, or at least one set of x's and y's that works. So let's make 10x and let's make 17y. We'll plug in the x and the y that we've got. 17 is equal to 2 times 10 plus b. So 17 is equal to 20 plus b, and this means that if you subtract that 20 over, b is -3. So you can put these two things together now to get the equation of the line. Y is equal to 2x minus 3 is what we're looking for. Put the 2 where the slope goes and put the -3 where the y-intercept goes. B is the same problem, but this time they didn't give us the slope. They told us the 2 points. But we've done problems like this recently, actually, with sequences. The first thing to do is to find the slope. You want to figure out the change in y divided by the change in x. The change in y is the distance from -2 to 5. You can do 5 minus -2 for that. You have to be consistent with the distance from 1 to -2. You got to do -2 minus 1. We're going to take the second number minus the first number. This is going to give us 7 on top, and that is -3 on the bottom. And that is unfortunate, but I believe that is what it is. It went down by 3 and up by 7. Yeah, that is the slope. That's unfortunate, but that's what it is. Now we're going to pretty much do exactly what we did in the last problem, because we know the slope is negative 7/3 times x plus b. We don't know what b is, but we actually have two different choices for x and y, and the cool thing is it does not matter which one you want to use. So let's go ahead and use the one with smaller numbers. Let's use 1 and negative 2. We'll make x equal to 1 and y equal to negative 2. That'll make our problem a little easier to solve. It'll be negative 2 equals negative 7/3 times 1 plus b. Now this is not going to be very fun because we are going to have to subtract over, or sorry, add over 7/3. I think I'm going to use the calculator for this and use decimals because I do not like working with this. Well, it's not terrible. So anyway, we're going to add 7/3 to both sides is basically what's going to happen here. So b is going to be whatever negative 2 plus 7/3 is. One way you can avoid using a calculator for this is rewriting the number 2 as negative 6 divided by 3. Which actually does make finding your y-intercept actually pretty simple, 1/3. We'll do the trick there. Negative 6/3 is negative 2. They're the same number. So now you got your b and you got your m. You can put them all together. It's going to be y is equal to negative 7/3 x plus 1/3. Question C is even easier because of a lot of reasons. First of all, they gave us, instead of giving us 2 points, they gave us 5 points, all arranged in a table. Excuse me, I'm hiccuping. There it is. They also just told us what the y-intercept is. B is negative 2, because when x is 0, that's your y-intercept. The only thing left to do now is figure out what the slope is, which is also pretty easy to do because on a table you can really easily look for the rate of change. For example, when x goes up by 3, y goes up by 2. And it doesn't matter which 2 points you choose to do that with. You can do that pretty much anywhere. X goes up by 3, y goes up by 2. This means that the slope is the change in y divided by the change in x, and that is 2/3. So now we know both pieces that we need. This is equal to 2/3 x minus 2. And that is all I have to say about it. Question D is over here. This one also just straight up told us what the y-intercept is. It's right there on the graph. Looks like 9, if I'm counting correctly. B is equal to 9. And then the slope you can find a lot of different ways. I mean, I don't like this picture very much because it's kind of tough to see, but I'm looking for the nearest lattice point. I'm looking along the grid. I'll see if I can do my cursor. I don't know if you can see that or not. I'm looking for the next point that goes right through the grid. Let's see. I'm tempted to say this point, but I don't think that's right. Over 4. No, it's not. It looks like it might be up through over 4, but I don't think it is. I think the next one is right there. That is over 4 and up. Man, I don't even know. From 9 to 19, up 10. And I think that pattern replicates itself. If I go over 4 again to the 8 spot and go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it'll be right there. So I believe that is the slope. I think that's the nearest lattice point I can find. So the change in y is going from 9 to 19. That's a change of 10. And the change in y goes from 0 to 4. That's a change of 4. So the slope in this case, m, is equal to 10 over 4, or 5 over 2. There we go. So the equation should be y equals 5 halves x plus 9. Tomorrow in class we have a brief quiz over some other stuff, and then we will look at some more problems like this. We will probably not do this checkpoint quiz until next week because we have a half day Friday, but we'll look at the schedule going forward. We'll probably look at this on Friday/Monday for my friends that I don't see on Friday at all. Excuse the hiccups. All right, see you guys in the next video. Doing great.